right, 8.3 is on synthetic division. Okay, synthetic division. Hang on. All right, synthetic division is another way to find zeros of a function. Okay, it's gonna, the way the questions are looking, it's gonna look similar to things we've done before. But there is a method and a reason for the synthetic division that we will get into next week. So in 8.3, this particular section, what we're going to be doing is just getting the practice of using the synthetic division. You'll have a problem like this: f of x equals x to the third minus 14x squared plus 59x minus 70. And we're going to be asked to find three different function values. The function value we're going to find first is f of 2. So you've done this before in a different way. If you're asked to find f of 2, one way to do it is to replace all those x's with 2's, right? We have done that before. Here's another way to find f of 2 using synthetic division. The value that you're looking for is going to be on the outside, and then you're just going to have what looks like a long division symbol. What's going in the division symbol are the coefficients of the terms of this function, right? Coefficient means number in front of, right? So the number in front of this x to the third is a 1. In front of x squared is negative 14. In front of x is 59, and then the constant is negative 70. Here are the steps to performing the synthetic division. Your first step is simply to drop down this first number to below the line. So I'm bringing down this 1. After that, whatever the number of function value you're trying to find, you're going to multiply it times the number below the line and put your answer underneath the next number. So 2 times 1 gives me 2. Now you're combining these two terms and putting a new number underneath the line. By combining, just combining like terms, or adding. Negative 14 and a positive 2 gives me negative 12. And you start the process all over. You multiply this value out here times the number below the line and put your answer under the next number. So here I've got 2 times negative 12, which gives me negative 24. And then combine this with the number on top of it. Or in other words, this time we're subtracting 59 minus 24, which gives me 35. And I keep going until there's just no more numbers to use. So this 2 multiplies by this positive 35, and your answer comes here. So positive 2 times 35 is positive 70. This answer, since there's no more numbers, is your solution. So negative 70, positive 70, if I combine that, I get 0. If this number out here ends up being a 0, like this one did, what that tells you about this number right here, that is a solution to this function. Or in other words, when I replace all the x's in this function with 2's, it'll give me 0, which means 2 is an x-intercept of this function. If I put this in y equals, one of the places it's going to cross through the x-axis is at positive 2, because this ended up as 0. If it ends up as any other number, then this number is not a 0 or an x-intercept. Okay? Another way to think about it is, this is a point on this function. If I graphed it, this would be in my table. The x being 2, when you do the synthetic division, this is the y that goes with this x. So there is a point, in other words, at 2, 0, which is why this is an x-intercept, correct? Because if your y coordinate of your point is a 0, What does that mean? If I plotted this point, 2, 0, I would go to the right 2, up and down 0. Look where that is, on the x-axis, which means it's an x-intercept, a solution, a 0. All those words can mean the same thing. So that's what you're finding, whether or not this function value, this x coordinate, is an x-intercept. It is if what ends up on that last spot is a 0. Okay, let's do it. The next part of this one says, okay, now using the same function, find f of -5. So all that's changing here is I'm doing -5 as my function value. In other words, I'm finding the y coordinate that goes with the x coordinate being -5. So if I end up again with this last number being a 0 right here, that means -5 is another place where this crosses the x-axis. If it ends up with something else, then it's not an x-intercept. So let's do the process again. Dropping down to 1. To give me a starting point, -5 times +1. Put your answer underneath the next number. So -5 times 1 is -5. Combine these, -14 and -5 is -19. And start over, -5 times -19. I don't know what that is. Gives me 95. Combine it with the 59 on top of it. 154. Last one, -5 times +154, and put your answer there. Gives me -770. And -70 and -770 is -840. So f of -5 is -840, which tells me what? -5 is definitely not a place where this function is going to cross the x-axis, right? That's way far away from 0. All right, last one for number 1 is find f of 7. So nothing's changing, right? I'm still using the same function, which means these coefficients are still the same. Starting off the same, just dropping down the 1. Start the process. 7 times 1 gives me 7. Combine it with the -14. -14 and 7 gives me -7. And do it again. 7 times -7 gives me -49. -49 is 10. And 7 times 10 gives me 70. So what's the solution? -70 and 70 is 0. So 7 was another x-intercept. All right, number 2, a new function. F of x is this time x to the 4th minus x to the 3rd minus 8x squared plus 42x minus 29. And what are we finding here? F of -3. So -3 is the function value that I'm looking for in this function. And remember, what goes underneath this long symbol are the coefficients of all these terms in this function. So my first coefficient in front of this x to the 4th, since I don't see it, is automatically a 1. In front of x to the 3rd is -1. In front of x squared is -8. In front of x is 42, and then the constant is -29. And we'll start the process. Drop down the 1 to give us a starting point. -3 times +1 gives me -3. Combine that with the number on top of it. -1 minus 3 is -4. Start over. -3 times -4 is +12. -8 and 12 is 4. So now -3 times +4. -3 times 4 gives me -12. If I combine that, add 42 minus 12 gives me 30. So the last one, -3 times +30 gives me -90. So what am I left with? -119. Right, number 3. My function is 2x to the 3rd plus 3x squared minus 14x plus 24. It wants me to find 2 function values. Then you'll notice that when you're writing in this answer, it's a multiple choice, and you have to choose which one is the correct even to write your answer in. Okay, and they're all going to start off with like the number -4 is a 0 because f of -4 is blank. The number 3 is not a 0 because f of 3 is blank. So let's find, we're going to find 2 function values, -4 and +3, and to see which one is a 0, which one is not, or if they both are, or if neither one of them are. Remember, the only way that a function value is a 0 is if the very last number at the bottom ends up being 0. So let's see, the first one is -4. We're going to use -4. My coefficients will be 2, 3, -14, and +24. Drop down your 2. Do the process. -4 times +2 gives me -8. Then to combine these, 3 and -8 gives me -5. Start over. -4 times -5 gives me +20. -14 and +20 is 6. And then the last one, -4 times +6 gives me -24. So what are you left over with here? 0. Here's what that says. That means -4 is a 0. Because f of -4 equals 0. So there's the first part of it. -4 is definitely a 0 because I was left over with 0. Okay, what about the next one? Let's try 3 in the same function. So my coefficients are still 2, 3, -14, and 24. Okay, again, dropping down your 2 to start. 3 times 2 gives me 6. I'll combine that with the +3 to get 9. So now I have 3 times 9. 3 times 9 gives me 27. When I combine this with the -14, I get 13. And 3 times 13 gives me +39. And if I combine that with the 24, let's see, what does that give me? 13. 63 is what's left. So what does that mean? That means 3 is not a 0. And why not? Because f of 3 is 63. It's not 0. So -4 was a 0 because f of -4 equals 0. 3 is not a 0 because f of 3 equals 63, not 0. All right, number 4. These are just yes, no questions, which means it's going to do the same thing. We're still doing synthetic division. And it's just going to ask you if your function value is a 0 or not, and then just give you a yes, no option. So in other words, if you end up like this, then your answer is yes. If you end up like anything other than 0 here, then your answer is no. All right, my function is h of x is x to the 4th plus 4x to the 3rd plus 2x squared minus 6x minus 1. We're finding two of them. So first thing is -2 a 0? So let's see what we get when we use -2. My coefficients in front of x to the 4th is a 1. In front of x to the 3rd is a 4. In front of x squared is 2. In front of x is -6. And then my constant is -1. So let's see what I end up with after synthetic dividing. Drop down your 1. So I have -2 times +1, which gives me -2. If I combine these, 4 and -2 gives me +2, and I go again. -2 times +2 is -4. 2 times, excuse me, not times, combining 2 minus 4 gives me -2. And again, -2 times -2 gives me +4. -6 and 4 gives me -2. So what do I have left? I've got -2 times -2, which gives me +4. So what are you left with at the end? 3, which means, is -2 a 0? No, it is not, because you didn't end up with a 0 down there. Right? Try this one. I'll pause it. Actually, I'll write it on the board and then pause it. is 1 a 0? So this time, same function. I'm going to use the 1 and see if it is a 0. Right? Now, I'll pause it for a second and let y'all work that real quick. Okay, let's see what we get here. If I drop down to 1. Start my process. 1 times 1 gives me 1. Combine these. 4 and 1 gives me 5. So now I have 1 times 5. Put my answer there, which is 5. Combine these. 2 and 5 gives me 7. Now, 1 times 7 gives me 7. When I combine these, negative 6 and 7 gives me positive 1. So now I have 1 times 1, which gives me 1. So when I do combine this with this last number right here, negative 1 and 1 is 0, which means is 1 a 0, or in other words, an x-intercept of that function? And that answer is yes, it is. All right, last one. Number 5. F of x equals x to the 3rd plus 5 halves x squared plus 13 halves x plus 15 halves. All right, so they threw some fractions in here, and I am finding is negative 3 halves a 0 of this function. So we're using negative 3 halves on the outside here. Put my coefficients in front of x cubed is 1. In front of x squared is 5 halves. In front of x is 13 halves. And my constant is 15 halves. Okay, so this one's not going to be quite as simple because it's got all those fractions. It's going to start off not too bad here, right? Just drop down your 1 like always. Then start your multiplication. Still not too bad because I have negative 3 halves times 1, right? Anytime you multiply something times 1, it's just what that other number is. So negative 3 halves times 1 is negative 3 halves. So even though these are fractions and I have to add them, or in this case, subtract them together, they have the same denominator, which makes this not near as bad, right? If I have 5 halves minus 3 halves, how many halves do you have? You've got 2 halves, right? Because 5 minus 3 gives me 2. It's going to be over 2. But what is 2 over 2? That's just the same thing as saying 1, right? So 5 halves minus 3 halves gave me 2 over 2, but that's just 2 over 2 is 1. Then start again. So still not too bad because I'm only multiplying times 1. So negative 3 halves times 1 gives me negative 3 halves. So again, I have the same denominator, so it's not bad. What do you get when you do 13 minus 3? That leaves you with 10. My denominator's 2. So how can I write that? Instead of writing it as 10 over 2, I can write that as 5, right? That's what 10 over 2 is. So what do I have left to do? I have negative 3 halves times positive 5. Now I am multiplying by something other than 1. So I'll do that over here to show you how to do that. Negative 3 halves times positive 5, and then I'll put my solution here. So when I'm multiplying and I have a fraction times a whole number, think of that whole number as over 1. So when I multiply, I just go straight across on top and bottom. So up top, I have negative 3 times 5, which is negative 15, over 2 times 1 is 2. So negative 3 halves times 5 gave me negative 15 over 2. So what's that going to leave me with? Positive 15 over 2 minus 15 over 2 leaves me with 0. So is negative 3 halves a 0 of the function? Yes, it is. Okay. All right. So